Hello everyone, welcome back to the channel, welcome back to the learning field. Just a second. Okay, so this session is the solution for what? GATE 2020 LPP solution. Okay, LPP का जो है complete solution, LPP complete solution. Okay, so we already solved the GATE 2022 paper and GATE 2021 paper. The link of the of those videos, you can get the link of those videos in the two playlist of this channel. Okay, so GATE, one is GATE mathematics, and number 2 is LPP LPP for GATE CSIR NET and SET. Okay, so in these two playlists you get the videos or solution of the LPP complete paper of 2022 and GATE 2021. Okay, so in this session we discuss the questions of GATE 2022 2020 LPP. Okay, so if you like the content, then please give a like to this video, share with your friends and subscribe the channel. Okay, so let's start. Let's start with question question number 8, which comes in GATE 2020. Okay, so the question says that if D1 and D2 denote the dual problems of the linear programming problem, P1 and P2, okay, these two P1 and P2 are the primal. Okay, where P1 equal to minimize x1 minus 2x2 subject to minus x1 plus x2 equal to 10, and P2 equal to minimize x1 minus 2x2 subject to this x1 minus x1 plus x2 is equal to 10, and x1 minus x2 is equal to 10, which x1 and x2 satisfies the non-negativity conditions. Okay, so these two are greater than, these two are the primal problem. Okay, so first we see this is a simple primal problem. So if we write the graph of this primal problem, okay, so this is the graph, I just write it, that is x1 minus x1, this is minus 1 0, so I just write minus 1 0, that is this point, sorry, minus 10 I think and 0, yes, minus 10 0 and 0 10. Okay, so 0 10, suppose this is the point and this is the line. Okay, and the region is, if we write the region, then 0 0 put not equal to, that means not satisfies, that means this side is the region, solution region. Okay, so that means what? That means this primal problem 1, that is P1, has unbounded solution. Okay, so P1 has unbounded solution, and we know that a theorem, if the primal or dual, if the primal problem has unbounded solution, then the dual problem has no feasible solution. That means the dual corresponding to the primal problem 1 has no solution. That means D1 is infeasible. Okay, D1 is infeasible. So okay, and P1 has an unbounded solution. Now we check the problem, primal problem P2. Okay, so here one constant is same, minus x1 plus x2 equal to 10, and x1 minus x2 equal to 10. That means what? X1 minus x2, that means 10, I think this one 10, x1 is 10 0, this is 1 point, and 0 minus 10, I think 1 point, I think this is 1 point, 0 and minus 10, you can check it once. Okay, so this is the line, and if we put 0 0, then this does not satisfy 0 0, that means this side is the solution. Okay, this is again an unbounded solution. Therefore for this problem, this is the two lines. Okay, so for this problem P2, the P2 has also unbounded solution. That means what? That means the dual of the primal problem P2, D2 of the primal problem P2 is also infeasible. So this is a very easy question. That means our answer is both D1 and D2 are infeasible. Okay, so this A is our clear answer. Okay, now let us go to the next question. The next question says that if x1 star and x2 star is the optimal solution of the linear programming problem, minimize x1 plus 2x2 subject to these two conditions constant. Okay, 4x1 minus x2, this is greater or equal to 8, 2x1 plus x2 greater or equal to 10, and minus x1 plus x2 less equal to 7. And lambda 1, lambda 2, lambda 3 are the optimal solution of its dual, then the value of the summation xi square, summation xi plus summation lambda j, okay, lambda j star, this is the optimal solution, and x1 x2 are the also the optimal solution of the primal. First we draw the graph of these three constraints and solve the primal problem. Okay, so let's see the graph. So this is the graph of the primal problem. This is one equation, I think this is equation 1, 4x1 minus, I just use minus 4x1 minus x2 equal to 8. This is second equation, minus x1 plus x2 equal to 7, and this is third equation, sorry, this is second equation, equation 2, equation 1, and equation 3. Okay, so these three are the constraint, sorry, constraint and equation. Okay, so first we see x1, 4x1 minus x2 greater or equal to 8. So if we put 0 0, then this is not satisfied, so that means the region is, okay, opposite to the origin. Okay, so first equation is, this is the equation 1. Okay, so that means what? That means this side is the region of this line. Okay, equation 1. Now if we see the second equation, we put 0 0, then this is also not satisfied, that means outside, that is opposite to the origin of this line. Okay, this is the solution region. The equation 2 is this one, that means this part is the solution region. Okay, and the third line is 0 0 less equal to 7, that means this is the same side of the origin. Okay, so this side is the region. That means what? We get the region in which side common side is this one. Okay, so from, just write, so this side. Okay, so this is the common region. Okay, now we have find the these points, and this point. Okay, these three are the point. Since the problem is a minimization problem, therefore we can get an optimal solution. Instead of this is what? This is unbounded, but we can get a solution because this is a minimization problem. Okay, so the points, this point is 3 4, you can calculate just this point. Suppose this point A. Okay, so A point is 3 4. Suppose this is point B is 5 0, and point, suppose this is C. Okay, this is B and this is C point is 5, and now we calculate the objective function at the point, these 3 points, that is z equal to what? X1 plus 2x2. Okay, so z equal to x1 plus 2x2. Okay, so we have to minimize z, that means the value 3 4 means at 3 4 the value is what? At 3 4 the value is 3 plus 8, that is 11. At 5 0 this value is 5, and 5 2, 5 plus 4, this is equal to 9. So this is the minimization problem. So this minimize the problem. That means what? X1 star equal to what? So since x1 and x2 star are the optimal solution of the primal problem, therefore we already get x1 star, this is equal to 5, and x2 star, this is equal to what? 0. So 5 0 is the optimal solution of the primal problem. Okay, now we apply here the complementary slackness property of duality. Okay, so it says that if the strict inequality occurs in the ith constraint of the primal in its optimal form, then ith variable of the dual is 0 in its optimal form. Okay, that means what? Since lambda 1, lambda 2, and lambda 3 are the optimal solution, now we check at this solution. Okay, at this solution, check these three constants whether this follows strict inequality or not. Okay, so if we put this optimal solution it here, so this gives 5 for the 20 minus 0. So this means this holds strict inequality. Okay, hold strict inequality. So if strict inequality holds, then what says? It says that then ith variable of the dual is 0 in its optimal form. Now it is given that lambda, this lambda star is the optimal solution of the dual. That means since this is strict inequality, this implies the first dual variable, that is lambda 1 star, this is equal to 0. Okay, now we put this solution here, So this is 10 plus 0, this is 10 equal to greater equal to 10. That means this is not the strict inequality, therefore we can't say about the lambda 2 star. Now we put this to here. Okay, so minus 5 plus 0, so minus 5, which is strictly less than 7. Okay, that means what? That means this is also strict inequality holds. That means this implies, since lambda 3 star is the optimal solution of the dual, that means from complementary slackness property we can say that lambda 3 star is equal to also 0. Okay, now we only to calculate the value of lambda 2 star. Now we go to the second part of the complementary slackness property. It says if the jth variable of the primal is non-zero in its optimal solution, then the jth constraint of the dual is a strict equality in its optimal form. That means what? That means we see first this x1 star is non-zero. Okay, that means what? That means in the dual form the it's occurs strict inequality in its first equation. That means what? Suppose we write its dual first. Okay, so this is a maximization problem. The dual is a maximization problem. Dual of this problem is a maximization problem. Okay, so maxima is what? 8y1 plus 10y2 plus 7y3. Okay, and the subject to what? Subject to 4y1 plus 2y2 minus y3. This is maximization position less equal to what? Less equal to 1. Here the coefficient is 1, and the next constant is minus of y1 plus y2 plus y3. This is less equal to what? This is less equal to 2. Okay, now since the first variable here, the first decision variable here in the primal problem is non-zero, that means what? That means in dual the first constant is holds the strict inequality in its optimal form. That means what? The optimal form is 4 lambda 1 star plus 2 lambda 2 star plus minus lambda 3 star. This is equal to 1. Okay, now the value of lambda 1 and lambda 2 star are 0. That means 2 lambda 2 star, this is equal to 1, and we get lambda 2 star, this is equal to 1 by 2. Okay, so we get all the values of x1 star, x2 star, x3 star, and lambda 1 star, lambda 2 star, lambda 3 star. Okay, so x1 star, this is equal to 5, x2 star, this is equal to 0, lambda 1 star, this is equal to 0, lambda 2 star, this is equal to half, and lambda 3 star, this is equal to 0. So we calculate this sum only. So this sum is 5 plus half. So 5 plus 1 by 2, this is equal to 5.5. Okay, so the answer is 5.5. So this is a very interesting problem, and the problem based on complementary slackness property and the dual of the primal problem. Okay, so now we go to the next problem. The next problem is I just hide the or forget to write the question number. Okay, so this is a transportation problem. It says that if what? x13, x23 and x22, x23 equal to 10 and x31, this is x3 to x34 is a set of basic variables of the balanced transportation problem seeking to minimize the cost of the transportation problem from the origin to the destinations, where the cost matrix is given by this, then the value of x32, we have to calculate the value of x32. Okay, so we all know that this side is called the sources of a transportation problem. These sides are the destinations. These sides, these are the what? These are the availability, and these are the demands. Okay, these are the demands. Now given that the transportation problem is a balanced transportation problem, that means total demand equal to total availability. Okay, so total demand equal to total availability. Okay, total demand equal to total availability. That means total demand equal to what? 10 plus mu minus 5 plus mu plus 5 plus 15. This is equal to, this is the availability, so 10 plus lambda plus 5 plus 3 lambda. Okay, so this means 10 goes to cancel, plus 5 plus 5 goes to cancels. So this is 2 mu plus I think 10, this is equal to just 4 lambda. Okay, so that means what, 4 lambda minus 2 mu, this is equal to 10. Yes, so this means 2 lambda minus mu, this is equal to 5. So we get a relation between lambda and mu. Okay, suppose this is relation 1. Now here the solution is a basic variable, so basic solutions already given, that means the allocations are given. Now first allocations is at x13 at x13. Okay, so if we write the availability at x13, that means 1 1 1 2 1 3, this is the availability, this is the allocation, primary allocation. X22, that means this is the x22, so there is an allocation. Then x23 2 3, so this is an allocation, and allocation is given, this is 10. Okay, x31, this is the x31, x32, this is the x32, and x34. Okay, so this is the x34. Okay, now here the availability is only 10 need. Okay, and here the only one allocation in this row completely. Okay, so that means this is 10, that means this complete availability is goes to this cell. Okay, so this is 10. So now that means, sorry, I just write once, d1 d2 d3 d4. Okay, d1 d2 d3 d4. Okay, that means we get here the total demand equal to total availability from the column d3. That means here mu minus 5, sorry, mu plus 5 equal to, we get what, we get 20. That means mu equal to, I think it is 15. Okay, so since mu equal to 15, therefore we get value of lambda, we get the value of lambda from this equation. So that means what, 2 lambda minus 15, this is equal to 5. This means 2 lambda equal to 20, and this gives lambda equal to 10. Okay, so we get lambda equal to 10. Now we go to the allocations. Now here the value is what, lambda plus 5. Just a minute. Yes, now since lambda equal to, yes, lambda equal to 10, so therefore this is what, this is the 15 value, and this is what, 3 lambda means 30 value, and this value is 10. This value mu minus 5 means 10, mu plus 5 means 15, and this is also 15. Okay, now since this is 15, therefore in this cell the allocation will be 5, because 10 plus 5 gives 15 unit. Okay, now we write here, since in this column there is only one allocation, therefore we just write 10 here. Okay, now we write 10 here, and here is only one allocation, and in this cell there is only 15 units needed, so therefore we allocate here 50, and since 15 and what, 15 plus 10 is 25, and there is the allocation is 30, therefore we have to give here the 5 units. Okay, so we get the value 5 units, and we need this value only, so we need x32. Okay, so x32 is what, x32 is this one, so x32 is means 5, so the correct answer is x32 is equal to 5. Okay, so this is a very easy problem. So this is the transportation problem. Okay, now we go to the next problem, and if this content is helpful, then please give a like to this video. Okay, because in the previous lectures I covered the I covered the theorems part of the LPB. Okay, so this is the question practice session. Now we go to the, and if you need the theory part, then you can watch the previous lecture of this playlist of the channel. Okay, now the next question is question number 42. Let alpha beta belongs to at an alpha not equal to 0, then the system, this one, x1 minus 2x2 plus alpha x3 equal to 8, and x1 minus x2 plus x4, this is equal to beta, x1 x2 x3 are greater or equal to 0, has no basic feasible solution. Their terms are basic and feasible. Okay, the terms, first we discuss these terms. I already discussed these terms in my class. Okay, in the channel you can available, you can get you can watch the lectures of the theory part. So feasible means what? Feasible means satisfies the non-negativity conditions. Okay, feasible non-negativity conditions. Basic means what? So we know if system, suppose the constant is ax equal to b and a equal to suppose a ij, it is an m by n matrix. Okay, now here the number of equations are, sorry, number of variables are m and number of equations I think n. Okay, so this m and n are maybe different. Okay, so in that case we get a over determined system. Okay, so to solve the over determined system, suppose there are n variables. Okay, n variables. Okay, and m is the number of equations. Okay, so suppose then we have to put, suppose this up to m and these are n, m less than n. Okay, so we have to put this n minus m basic variables at to 0. Okay, so these variables which we put 0 to solve the system or to convert this system to a balanced system. Okay, so these basic variables, these variables are called the non-basic variables. We already discussed it, and these m variables are said to be the basic variables. Okay, so basic variables, that means what? Basic variables with non-negativity condition is the basic feasible solution. Okay, we first have to understand this and then we go to the solution. Now one more thing is that if there is m variables with n unknown, then there are and here it is given that there are 2 equations and 4 unknown. Okay, sorry, 4 variables, 2 equations with 4 variables. So here we get 4c2, that is 6, total 6 6 possibility we can get. Okay, total possibility to get the solutions is 6. Okay, now we have to solve this system by putting or by choosing the some variables is to be 0. Okay, we can't solve the system otherwise. Okay, to solve this system we have to put the variables, 2 variables at a time at 0. Okay, because this is a 2 equation and 4 unknowns, therefore we have to put any 2 basic variables 0 and the combination are 6, therefore total 6 combination we can get, or we can put the 2 variables 0. Suppose first we choose x1 equal to 0 equal to x2, then suppose choose x2 equal to 0 equal to x3. Okay, x1 x2, first choose x2 x3, then choose x3 equal to x4 equal to 0. These are the possibilities. You can get other 3 possibilities also. Okay, so if we choose x1 equal to 0 equal to x2, okay, suppose x1 and x2 equal to 0, then if we put it to here, then we get what? Then we get x1 means 0 minus 2 into 0 minus 2 into 0 plus alpha x3, this is equal to 8, and this gives x3, this is equal to 8 by alpha. Okay, now it says that it has no basic feasible solution. That means what? That means either it is not basic or it is not feasible. Now it is given that alpha is not equal to 0. That means this 8 by alpha is not less than 0. Therefore this must be basic. So this case is not, we can't discard these options by this basic. Therefore we go to the feasible section. That means what? Feasible means it satisfies non-negativity condition. If it is basic feasible solution, then it must satisfy the non-negativity conditions. Okay, but here we have to find the no basic feasible solution. That means what? That means this x3 must less than 0. That is why it is not a basic solution. Okay, so if this is less than 0, then it says that alpha is less than 0. Alpha must be less than 0. Understand or not? I think I said very easily and very easy way. So okay, so you can understand it. Therefore we can discard the remaining options in which it is given alpha greater than 0. That means this option discarded and this option is also discarded. Okay, now alpha, we get one solution, alpha is less than 0, and now we have to find the conditions on beta. Now if we go to the next choice, and if we put this solution to the second inequality, then we get this 0, that is 0 minus 0 plus x4, this is equal to beta, but we can't get any conditions on beta from here. Okay, so we go to the next one. So if we choose this possibility now, In that case, if we put these two values in the given equations, we get what? We get, see, x1, x2 and x3 0. That means these two are 0. So 0 minus 2 into 0 plus alpha into 0, this is equal to 8. Sorry, this is x1. So this gives x1, this is equal to 8. This is obviously greater than 0, therefore we can't say, we can't here हम लोग कुछ नहीं कर सकते, ठीक है. So now if we put this x2 equal to 0 and x3 to the second inequality, then we get x1, okay, 2 3 plus x4, this is equal to beta. Now we get already the values of x1 which we put here, so which is equal to 8 plus x4, this is equal to beta. Okay, so this is equal to, this implies x4 equal to beta minus 8. So for choice of x1, sorry, x2 and x3 equal to 0, we get what? We get x1 equal to 8 and x4 equal to beta minus 8. Now if it is not a basic feasible solution, that means it must what? Since beta can 0 or not 0, so we can't go to the basic part. Here we also go to the feasible section. That means what? This must satisfy the does not satisfy the non-negativity condition. That means what? x4 must less than 0. Okay, because greater equal to 0 is case of non-negativity condition. Okay, so this is must less than 0. That's why this is has to be a no basic feasible solution. If this is less than 0, then this is has no basic feasible solution. That means what? B minus 8 is less than 0. That means beta is less than 8. Therefore we get the conditions on alpha and beta. So alpha is less than 0 and beta is less than 8. So yeah, our clear cut answer is option number D. Okay, so this is the solution of the question 42. Now we go to the next question, and I think this is the last question, right? Okay, so the next question, the question says that let alpha let alpha be an optimal solution of the linear programming problem. This x1 plus x2 minus plus x3 minus alpha x4 subject to the constant. There are two constants. Then the maximum value of beta minus alpha is. Okay, now in this problem, duality needed or not? I think duality is also needed. Okay, so 3 0 0 beta is the optimal solution. Therefore we can this satisfies these two constraints. Therefore we put the values of this optimal solution to the constant first. So 2, we write 2 x1 means 3 plus 0, sorry, minus 0 plus 0 plus 0, this is equal to 6. So 6 equal to 6, we get nothing. If we put into the second constant, then we get minus 3 plus 0 plus x4 means beta, this is equal to 3. Okay, so we get beta equal to 6 here. Therefore the optimal solution of the primal problem is what? 3 0 0 6. Okay, so this is the optimal solution of the primal. Okay, now beta ho gaya find. Now we have to find the value of alpha. Okay, so to find the value of alpha, we go to the dual of this problem. Okay, so this is a minimization problem, therefore dual of this problem is must be a maximization problem. So maximization of what? Suppose 6y1 plus 3y2 subject to what? Subject to 2y1 minus y2, which is maximization problem less equal to 1. Second one is minus y1 plus y2, which is less equal to 1 again. Then x3 only, so minus y1 sorry y1 plus y1, which is less equal to again 1, and then only x4, so y2, which is less equal to minus of alpha. Okay, so these four are the constant of the dual. Okay, now here we already also have to apply the what? Weak duality theorem, sorry, complementary slackness theorem. Okay, so here we also apply complementary complementary slackness. We have to also calculate the complementary slackness theorem. Okay. So first we see that this x1, sorry, here the x1 and x3 are non-zero. Okay, that means what? If the ith constant is a non-zero, then the corresponding constant in the dual in its optimal form are what? Strict inequality. That means what? Suppose y1 star are the optimal solutions, therefore to y1 y2 star are the optimal solution of the dual, therefore 2y1 star लिख लेते हैं यहाँ पे y1 star and y2 star are the optimal solution of dual. Okay, that means y2 y1 star minus y2 star, which is equal to 1, and y2 star from the fourth, this is equal to also minus of alpha, I think. Yes. So now we get two equations with two unknown. Now put the value of y2 star from it to here to this equation. So 2y1 star minus minus alpha, so plus alpha, this is equal to 1. So this means y1 star, this is equal to what? This is equal to 1 minus alpha by 2. So we get the value of y1 star and y2 star from here. Now the second part of the complementary slackness theorem says that if these variables are 0, or okay, these variables are 0, then we have to check what the complementary slackness is. What? I also forget that. Just a minute. Strict inequality, I think. This is strict inequality, I think the corresponding the corresponding constant follows strict inequality or not. So if write this here, to y1 is less equal to alpha. So if we put the value y1 star is less equal to alpha here, so y1 star, this is equal to 1 minus alpha by 2, which is less than 1. Okay, this is equal to strict inequality. So this is equal to 1 minus alpha, this is less than 2. Okay, so less equal to 2 is satisfied. Only we write this value of y1 star, since this is optimal form, therefore this satisfies this constant. Okay, so which is equal to alpha is greater or equal to minus of 1. So we have to find the maximum value of beta minus alpha. Okay, so maximum, and since alpha with a negative sign, therefore, and we get here, this is the what? This is the minimum value of alpha. Minimum value of alpha is minus 1. That means we have to maximize this beta minus alpha. Okay, we have to maximize this beta minus alpha, and we get the minimum value of alpha, and value of beta is fixed. So value of beta is fixed, and this is the minimum value of alpha, and this is the we have to maximize this. Okay, so that means the maximum value of beta minus alpha, since alpha is a negative sign, therefore we put the minimum value of alpha in to here to get the maximum value of beta minus alpha. Okay, so this is equal to beta minus beta value of what? Beta, the value of beta is 6 minus of 1. Okay, so this is equal to 7. I think the correct answer is 7. Okay, so this is 7. Okay, so this is the complete solution of the GATE 2022 2020 mathematics LPP section. Okay, so if you like the content, then please give a like to this video, share it with your friends, and subscribe the channel. Okay, see you again in the next video. And one more thing is that we are very close to 1K subscriber, so please like, comment, share, and subscribe to grow more, to grow fast. Okay, thank you.